Hi guys, today we're going to go through the last two examples for integration using partial fraction. So as you can see, okay, this example involves improper rational function, right? So what is improper rational function? So the definition is something like that. Degree of the numerator must be greater than or equals to the degree of the denominator. Okay, so in this case, in our example here, the degree of the numerator here is 3, 3, and the degree of the denominator is also 3, so they are equal. Okay, so that means it satisfied the improper rational function. So this is an improper rational function. So the whole fraction here is your improper rational function. So if that's the case, so what should we do? So we have to convert to, so we need to convert to what? Convert to proper rational function. There are two ways, either by long division or by inspection. Okay, so okay, for this example, I'll be using inspection method. Okay, so let's see how to go about it. So let's say x cubed. Now we are doing the working to convert to proper fraction. X cubed minus 4 over x cubed plus 2x squared plus 2x. So first step, the inspection method, as we learned before, you write down the denominator on the numerator position. So over, okay, so first you write down the denominator on the numerator position. So you see, you introduce two extra term, x squared plus 2x squared plus 2x. Why? There are new terms on the numerator because there's no 2x squared plus 2x from the question. Okay, so in order to retain the question or retain the validity of the question, we must minus off 2x squared plus 2x bracket. Okay, so after this step, after minusing, so this one will give us x cubed. Okay, but don't forget the question has a minus 4, so we must minus 4 behind. Okay, so then we write down the denominator. So we fill out the denominator again. So now we split the fraction. X cubed plus 2x squared plus 2x over x cubed plus 2x squared plus 2x. So now we split the fraction, so that once the one with the denominator on the numerator expression on the numerator will group one side, and then the rest will be behind, will be the next term. So like that. Now we simplify. Now this is the same, so it goes to 1. Now this one you cannot simplify, right? So you have to factorize. So this is the part. So this is the part that you need to use partial fraction. Okay, so we at the same time factorize the denominator. Okay, write down the numerator. Okay, so now we may need to use partial fraction. Now before you can use that, before you use that, actually there's a 2, so we can take out common factor. So now instead of using partial fraction, sometimes we can use inspection also. How? So you look at this expression. You can do as inspection idea. So x squared plus 2x plus 2 minus x, correct, over x squared plus 2x plus 2, right? So now again you can split. Okay, you can split, become x squared plus 2x plus 2 over x bracket x squared plus 2x plus 2 minus x over x squared plus 2x plus 2. So what are we trying to do here? Now we're trying to do a kind of simplifying process. So this and this is the same, can cancel, and this is the same, right? So eventually it has a result of a partial fraction. It has the same result as if you do partial fraction. So sometimes there's some shortcut. So in this question you can use this as a shortcut, right? So after inspection, now we can do the integration, right? So therefore integrate x cubed minus 4 over x cubed 2x squared plus 2x dx equals to integrate 1 minus 2, right? 2 bracket the whole thing, because that's our inspection result. Instead of using partial fraction, I use inspection method, right? So after that we can integrate individually, just like what we did in the last few questions. So 1 dx minus 2 you can take out, 1x dx plus 2 also 1 over x squared plus 2x plus 2 dx. Okay, so this is the first one is x minus 2 ln x plus 2. Now how do we integrate this? Okay, so to integrate that we need to learn some new formula that involve inverse tangent, okay, so I will introduce here. So the new formulas are here, like that. So you have to use this formula when you see a question with quadratic irreducible quadratic factor. So this is irreducible, irreducible quadratic factor, IQF. Why? Cannot be factorized. Okay, so this cannot be factorized, so you have to use completing the square later. So before we do that, when it cannot be factorized, then you definitely have to use completing the square. Okay, now why? Because, okay, I will show you the formula first. So if you integrate 1 over 1 plus x squared dx, the formula is tangent inverse x, of course plus c. Then later if you integrate a square plus x square dx, now the formula is 1 over a tangent inverse x over a plus c. Okay, so the next advanced formula, which is very useful, will be a square plus x plus b bracket square dx. Okay, so you have this form, so you have to use the formula 1 over a tangent inverse x plus b over a bracket square plus c. So sorry, no square. So x plus b over a bracket, and this is a. Okay, so I recommend you to actually write these two formula in your cheat sheet. Okay, so I recommend you to write these two formula in your cheat sheet. Okay, so it's very important. Okay, so how to make use of this formula in this question? So we'll see. Now we just isolate the question. 1 over x squared plus 2x plus 2 dx. Now in order to get this type of bracket square, okay, you have to use completing the square. There must be completing the square involved. So integrate 1 over, so x squared plus 2x plus, now this is where the completing the square comes, plus 2 over 2 square minus 2 over 2 square, then plus 2. Okay, the plus 2 is from the question, right? So dx, so then equals to integrate 1 over, now these 3 will give you your completing the square, so x plus 1 bracket square and minus 1 plus 2 dx. So here you get equals to 1 over 1 plus x plus 1 square. Okay, so you can use this formula. You can use this formula, this one. So you can use this formula. It means in this case, your a is 1 and your b is also 1. So you get this 1 over 1 tangent inverse x plus 1 over 1 plus c. So of course the answer will be tangent inverse x plus 1. Now because this is part of the whole question, we don't plus c first. We plus c until we finish the whole question or the integration of the question. Okay, so you know this tangent inverse x plus, so we sub in back to the question now. So let's say this is 1, equation 1, and this is equation 2, so sub 2 into 1. Okay. So eventually you have integrate x cubed minus 4 over x cubed plus 2x squared plus 2x dx equals x minus 2 ln just x plus 2 tangent inverse x plus 1 plus c. Okay, so this is your c. Yes, so finally we finish the question. Okay, so next we'll be going to do the next example, the last example for integration. So the last example I will continue in the next video. Okay, so I see you again. Thank you very much for your attention.